keep building. Now, we've been looking at sets for the last 5-6 lessons. Now, we're continuing sets, but we're looking at sets of different dimension. Today, we're going to look at numerical problems. And we're going to take Venn diagrams and solve problems to find values. I denote my universal set with U. I have my set A and my set B. Now normally we're accustomed that if we have our universal set and our subsets in them, let's say we have X and Y, we're accustomed to seeing the elements. So we have 2 here, 9, 3, 5, 8, maybe 6, 21, 32. Those are the elements. But when we look within X, how many elements are in X? 2. So the number of elements in X is equal to 2. The number of elements in Y is equal to 4. So we have here as all of Y. Good. Now when I insert the numbers in here, those numbers would be the cardinal numbers of the set. We call these the cardinal numbers. How many elements are in them? So let us say we have 5 here, 3 there, and 8 here. So we rewrite like this. Number of elements in the set A is equal to, for A, we have this entire loop. So how many elements are found in here all together? It would be, and how did we get our 8? 5 plus 3. The 5 represents those who are in A only, and the 3 represents those who are shared by A and B. And 5 plus 3 will give us an 8. So 8 elements are in all of A. Number of elements in B would give us number in B only, which is 8, plus the number in B and A, which is 3. And 8 and 3 would give us 11. And when we look again, we have 1 region, 2 region, 3 region. If we look at this region, that region would be number in and both. How do I write the both? A intersect B. And that would be equal to 3. Now we intersected A and B. We want the number in A union B. And A union B, as we said, it's all of A and all of B. And all of A would be 5 plus 3 plus 8 plus 3. Isn't that so? But when we look at A and B and the intersection, this here would give us 5 and 3, 8 and 8, 16 and 3, 19. But when we look in here, do these numbers tell us that there are 19 elements there? No. So we say number in A union B is not equal to, this here would have been the number in A plus the number in B. A union B is not equal to number in A plus number in B. Yes, Damien?
This is 19.
It's 19 and not 9. Thank you very much, Damien. Very observant child. Good. So, why can I say number in A union B is not equal to number in A plus number in B? Why do I put the slash across the equal sign? Because I have to use A only and B only. And what else can you observe here?
Along with the intersection.
The 3 is repeating. Here we have the 3 and you have the 3 here. So if the 3 is being repeated, it means we have to take it out. We have to take 1 out. So we rewrite number in A union B as the number in A plus the number in B. And what are we going to do now? And what are we going to do there? What operation? Look up here. We have 5 plus 3 plus 8 plus 3. So we see the 3 recurring. So we're going to take out 1 3. So number in A intersect B. So let's see. Number in A is going to be 8 plus the number in B, which is 11. Take 3. And how much do we have? 16. So we have 8 and 3, 11 and 5, 16. So as long as 2 sets intersect, the number in A union B is equal to the number in A plus the number in B, take the number in A intersect B. So you can quickly take this equation down. Good. Now let's look at this example across here. In a survey of 50 students, it was found that 23 own digital cameras, 18 own digital recorders, X owned both cameras and recorders, 2X owned neither. So imagine somebody walks into your school, a pollster, and they conduct a survey. They select 50 students and they collect, that's a sample. From that sample, they found that 23 students own digital cameras. 18 students own digital recorders. And X own both, while 2X own neither. The first thing they want us to do is draw a Venn diagram and complete it with the information that is given. That's the first thing we're going to do. So let's draw up our Venn diagram. So we have our universal set. Now we need to name our subsets. There are 2 of them. One is cameras and one is recorders. So we let C represent those that own cameras, and we let R represent those who own recorders. So we have R and we have C. Good, let's go. So they say, let us start with the X. Where should we put the X? In the region of intersection. So we put our X here. According to our information, the entire recording is 18. We want recording only, which is here. What should we put in here? 18 take X. And across here, the entire loop here would be for cameras. And across here we would have 23 take X. So we have the X, the 18 and the 23. the 2X is still out there. The 2X, they don't own cameras nor recorders. So will they be found anywhere inside here?
No, miss.
No. They're within the universal set, but outside of the loops. So we'd have our 2X here. So here we have represented the information they've given us on a Venn diagram. Let's move on to the next piece. Write an expression in X to show the number of persons in the survey. Write an expression in X to show the number of persons in the survey. So when we're finished, we must have an expression with terms of X. Everyone in here was a part of the survey. Those who are recorders only, both recorders and cameras, cameras only, and those who have no recorder or camera. So we write our expression, means that we're going to take all our regions and put them together. And when you look at our expression, you must see terms in X. So what's the first term I'm going to write? 18, take X. Then we're going to add that to X. Then add it to and what we have next? 2X. And this here is what is called an expression with X terms. See the X's there? The third part asks us to calculate the value of X. So we want to know how many students own recorders and cameras, and how many students do not own recorders and cameras. Also, who own recorders only or cameras only. So when we find X, we'll be able to determine these numbers. Part 3. In order for us to find X, we're going to have to take the expression and use it to make an equation. Now, how many persons were in the survey? 50. So, 50 now has to be equal to all of this here. So, we're going to have 18, take X, plus 23, take X, plus 2 X's. 50 is equal to, when we sum our 18 and our 23, what did we get? 4 to 1. And we have a negative X and a negative X, and that would give us a minus 2X. And a 2X and an X would give us a positive 3X. So we have 3X, take 2X would leave us with an X. So we want to get the whole numbers together on one side. So we're going to bring across the 4 to 1. And here we'll have 50, take 4 to 1 equals X. Therefore, 9 is equal to X, or X is equal to 9. So 9 students own both digital cameras and recorders. So if we should substitute or fill in our X here, X equals 9, then how many students own recorders only? 9, which is 18 take 9, and that would give us a 9. Cameras only would be 23 take 9, 14, and here we'd have 2X would give us 18. Now when we sum 18, 9, 9, and 14, we must have 50. So we have 18 and 9 would give us 27 and 9, 36 and 14 would be 50. So we have an equation there that is balanced. Everybody understand that?
Yes, miss.
Good. Now here's your turn. Let's first go through the question. Again, another survey was conducted, but this one was conducted with tourists. They took a sample of 40 tourists in this survey, and it was discovered that 28 visited Antigua, 30 visited Barbados, 3x visited both countries, and x visited neither. And these questions are all past CSEC questions. Good. The first thing I want you to do is to draw a Venn diagram, and I want you to show the information, display the information given on that Venn diagram. When you're finished with that, I want you to write an expression in X to show the number of tourists interviewed. And then finally, I want you to solve to find the value of X. So let's start with the intersection region. What do we have here? 3x. So if 3x takes up this portion of A, then the remainder of Antigua will be? What will be in Antigua only? 28 take 3x. Therefore, in Barbados only, we'll have 30 take 3x's. And those who visit neither Barbados nor Antigua would be x. Now, when you would have been working questions like these, you're accustomed to x being here. So what you notice is that you must be able to adapt. Be careful. You just don't train your mind one way. Good, so there's our Venn diagram. The second thing they wanted was an expression. So we're going to put all the regions together to show all those who were interviewed. So we have Antigua only, which is 28, take 3x. We had both Antigua and Barbados, and that was
3x.
And that's followed by
Plus 30 minus 3x.
And we add an x to that. So the third portion, we have to find the value of x. And to find the value of x, we made use of all those who were interviewed, as well as our expression. So we form our equation. 28 take 3x plus 3x plus 30 take 3x plus x equals 40. Good. So when we added our 28 and our 30, which are our like terms, they're whole numbers or constants, when we added 28 to 30, what did we get? 58. 58. So we have here a 3x, and an x would give us a 4x. And then we have a negative 3x and a negative 3x, and that would give us a negative 6x. And that would give us 40. If we have a positive 4 and a negative 6, these are like terms, so we can go ahead and solve these. When we finish working out this here, what would be your result here? Negative 2x. And our 58 comes down, is equal to 40. Now we are interested in finding out the value of x. Okay? So we're going to try to get 40 and 58 on the same side of our equation, because we can solve, we can work with those two. And we're going to have x alone on one side. So we're going to bring the 40 across with our 58. And that is equal to 2x. 58 take 40 would leave us with 18. And that's 2x. Therefore, 18 divided by 2 is equal to x. And x is equal to? 2 1s are 2, 2 9s are 18. X is equal to 9. So it means that 9 students, it means that 9 tourists visited both. It means that 9 tourists didn't went to
Antigua or Barbados.
good. And how many tourists went to both Antigua and Barbados? 27. Because here we have 3 x's, which would be 3 by 9, and that would give us 27. Good. Questions now.
Can the sum be worked in a different way?
Can the sum be approached in a different way? You want the 40 in front and the expression at the back? What?
From 58,
Yes.
take 2x equal 40.
Mm-hmm.
Could it take the 58 and take it over to the 40?
Yes.
And it would have been negative 18.
Yes.
You would have got negative 2 divided by negative 18, which would have given you 9.
That is also correct. That is also correct. So at this stage, instead of having the 40 come across to the left-hand side and the negative 2x going across and becoming positive, what we could have done also is have the negative 2x is equal to the 40, take 58. So we have a negative 2x equals a negative 18. X is equal to negative 18 divided by a negative 2. And when a negative is divided by a negative, our result is a positive. So there's another alternative when you get there. Also, when we got into the expression here, what you notice is that this negative 3 could have been cancelled out with this positive 3. And when you look here, from these 3 negatives, we could have taken out 1, and that would have left us with 2. So there are several ways you can go ahead. Okay? Any other question? Fidelity? Miracle? No question. So you see how we can use Venn diagrams to solve sets or find unknown values of sets. So you can do surveys, use Venn diagrams to give us answers. Okay? Good. Now it's your turn to tell me what part of this lesson you're going to take back to your class. Miracle.
Writing expressions in X.
Writing expressions in X. And you must remember that when they're saying in terms of X or in X, it means that when you look at the expression when you're finished, you must see X terms. You must see X terms. So there's nothing to be afraid of there. Okay? Now let us quickly recap what we did. Now look here. Sets, numerical problems. In this lesson, we will use Venn diagrams to solve numerical problems arising from the intersection of 2 sets. Here are some key points. The number of elements in set A is denoted by when 2 sets A and B are disjoint, number in A intersect B is equal to 0. We can use Venn diagrams to help us solve mathematical problems. Let us study the Venn diagram carefully. Number in P is equal to 8 plus 4 equals 12. Number in Q equals 7 plus 4 equals 11. The number of elements in the set P intersect Q is equal to 4. Number of elements in the set P union Q is equal to 8 plus 4 plus 7 equals 19. The number of elements in P union Q is not equal to the number of elements in P plus the number of elements in Q. Why? Here is a very important relationship. Number of elements in P union Q is not equal to the number of elements in P plus the number of elements in Q, but number of elements in P union Q is equal to the number of elements in P plus the number of elements in Q, subtract the number of elements in P intersect Q. We must take out one number in P intersect Q. 19 is equal to 12, add it to 11, take 4. Example 1. All pupils in a class of 25 take mathematics or science. If 15 take mathematics and 16 take science, how many take both? Solution 1. The set M is equal to the set of students taking mathematics. The set S equals the set of students taking science. Then, the set M intersect the set S is equal to the set of students taking both mathematics and science. The number of elements in the set M union S is equal to 25. Number of elements in the set M is equal to 15. Number in S is equal to 16. The number in P union Q is equal to number in P plus number in Q take number in P intersect Q. Substituting, we have 25 take 15 plus 16 take number in M intersect S. 25 take 31 is equal to the negative of the number M intersect S. Then number in M intersect S is equal to 6. Take both maths and science. Solution 2. The set M is equal to the set of students taking mathematics. The set S is equal to the set of students taking science. X equals the number of students in the set M intersect S equal to the set of students taking both mathematics and science. Number of elements in the set M union S is equal to 25. Number of elements in the set M is equal to 15. Number of elements in the set S is equal to 16. 15 take X plus 16 take X is equal to 25. 15 plus 16 take X is equal to 25. 31 take X is equal to 25. Take both M and S. X is equal to 6. Example 2. In the Venn diagrams below, shade the region that represents the set indicated. 1. P union Q. 2. P intersect Q. Solution. In the Venn diagrams below, shade the region that represents the set indicated. 1. P union Q. 2. P intersect Q. Example 3. In the Venn diagrams below, shade the region that represents the set indicated. 1. P intersect Q complement. 2. P complement union Q complement. Solution. What can we say about P intersect Q complement and P complement union Q complement? Summary. Venn diagrams represent sets by enclosed regions which are often drawn circular. U, the set of the universal set, is often rectangular. If two sets A and B intersect, then the number of elements in the set A union B is equal to the number of elements in the set A plus the number of elements in the set B. Take the number of elements in A intersect B. Problem for today. Page 33, exercise 3D. Questions 4 and 8. Mathematics for Secondary Schools in Guyana, Book 3. Solution for the problems given in the last lesson. Page 30, exercise 3C. Given that the set X is equal to X such that X is greater than and equal to 6, lesser than 11, X is equal to the set of natural number, and the set Y is equal to X such that X is lesser than 7, X is an element or member of the set of natural numbers. 2. List the elements of X union Y. X is equal to 6, 7, 8, 9, 10. The set Y is equal to 1, 2, 3, 4, 5, 6. The set X union Y is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Given that X is an element or member of Z, describe 4. X such that X is greater than -2, lesser than 2, intersect X is lesser than 3 using set builder notation. X such that X is greater than or equal to -1, lesser than or equal to 2. 6. Write down the name of the regions which can be described as A. R complement intersect G complement, region 4. B. R intersect G, region 1. C, R union G, regions 1, 2, 3. D, R union G, complement, region 4. E, R complement intersect G, 3. F, R, 1 and 2. Now I hope you had a lot of fun in what we did today, and I hope that whatever we're doing now is going to help you to build a very good foundation in mathematics. You become better in it, and when you're ready to write your CSEC exams, we have all these things